Welcome everyone to GENUIS Grades. This is tutorials on Enzymology BCH 401. The first question on this tutorial sheet says, what are the units of the rate of 0, first and second order reactions? What are the SI units? We are going to state the rate formula for this and then depict its SI unit. Okay, for the first, we are going to depict the SI unit for 0 order, first order, and second order. Note that the rate for the 0 order is equal to K times the concentration of A to the power 0. For first order, the concentration of A is to the power 1. For second order, the concentration of A is to the power 2. Okay, for the 0 order, rate is equals to K. First order rate is equals to K times the concentration of A. Now, for the second order, rate is equals to K times the concentration of A to the power 2. We should know that the rate is equals to the concentration divided by the time, which the SI unit for the concentration is mole per dm cube and time seconds. So it's mole per dm cube per second. Okay, that means for the 0 order where rate is equals to K, we have SI unit mole per dm cube per second. While for the first order, rate, if we do the subject of formula K is equals to rate divided by the concentration of A. If we put the SI units as shown there, K will be equals to per second. Please follow up. While for the second order, K is equals to rate divided by the concentration of A to the power 2. Now we have 2 mole per dm cube. We do the cancellation, it will give us mole per dm cube per second. The second question says, if a first order reaction is half completed in 2 seconds, what is the rate constant? Now, B, we should know that T half is equals to 2 seconds in this case. T half equals to 2 seconds, which is equals to 120 seconds. Note this. When we are looking for the rate constant, we are looking for the rate constant, which is equals to K. So T half is equals to 0.693 divided by K. Okay, K, if we do subject, we look for the subject of formula, putting K as a main subject. K is equals to 0.693, that's ln 2, divided by T half. 0.693 divided by T half, and we know our T half is 120 seconds. So putting the figures there, K and 0.693 divided K will be equals to 0.0058 per second, because we are talking of the first order. Always note your unit with respect to the order per second, because we are dealing with the first order reaction. Okay, now C, question 1C of this tutorial says a certain first order reaction is 45% complete in 65 seconds. Determine the rate constant and the half-life for this process. Okay, we are to determine the rate constant, the half-life for this process. Remember, this is a first order reaction. So for the first order reaction, take note of this formula. Ln the concentration of A is equals to negative the rate constant times time plus ln the initial concentration of A. Okay, we should note that 45%, according to the equation, they said 45% of this reaction is complete. 45% of this reaction is complete, which implies that 55% is left uncompleted. Yes, which implies 55% is left uncompleted. So A, which is the final, which is the one left, the percentage left, we will take 55 divided by 100, which will give us A equals to 0.55, and the initial concentration A0 is equals to 1. So if we are imputing the values, we have ln A equals to negative KT plus ln A0, initial concentration. Inputting the values, we have ln 0.55 equals to negative K into 65, because they said 45% is complete in 65 seconds. So T there is 65 plus ln 1. So making K subject of formula, we have negative K equals negative 0.598 divided by 65, which is T. Negative K equals to negative 0.598 divided by 65, implying K is equals to 9.2 times 10 to the negative 3 per second. Why per second again as the SI unit of K? Because we are talking of the first order reaction. Always take note of the per second, because we are talking of the first order reaction. So having K, which is 9.2 times 10 to the negative 3 per second, we can calculate our T half. Yes, we can calculate our T half. We can now have our T half, which is the second part of the equation. So we should calculate the rate constant. So our T half is equal to ln 2 on K. Inputting the values, that's 0.693 divided by 9.2 times 10 to the negative 3, which is K, we have 75.30 seconds. That's the T half. Okay, the D part says calculate half-life for the first order reaction if 68% of a substance is reacted within 66 seconds. At what time after initiation of the reaction will 10% of reactant remain? Okay, this is the D part. T half of the first order reaction is given by this formula, ln 2 times T. That's the time where 68% of the substance is reacted, divided by 2.303, the log of the initial, that's A0, the initial percent, which is 100, divided by the remaining, that's the final concentration, which will be gotten as shown below. So collecting the data, we have T equals to 66 seconds. 66 seconds, according to our equation, is the time when 68% of the substance is reacted. A0 is the initial concentration, which is 100%. Initial concentration before the start of the reaction process was 100%. We are dealing with percentages here. Why now the final concentration 80 is gotten by 100 minus 68%, which is already reacted. So the unreacted concentration is 100 minus 68, which equals to 32. Now our T half, therefore our T half is gotten by ln 2 times 66 seconds, the time, divided by 2.303 log 100 on 32. Ln 2 times 66 divided by 2.303 log 100 on 32. Hence, if you punch that with your calculator, you have T half equals to 40.13 seconds. 40.13 seconds as a T half. Now the second part of the equation says at what time after initiation of the reaction with 10% of the reactant remain. Now the time, note this, the time at which 10% of reactant will be left is the same as, or it means 90% of the reaction is complete already. So they can turn and ask that calculate the time. They can say at what time after initiation of the reaction is 90% already reacted. It's the same question but in another phase. So yeah, it means 90% of the reaction is already complete. Hence we will have our T following T, our reaction of our equation. We have T equals to 2.303. T equals to 2.303 divided by K times log 100/10. We are talking of percentage here. Log the initial 100 divided by the percentage which is T to be reacted. Like how we did up here, we're dividing 100 on the 32, which is the unreacted concentration. So here is 100/10. And we know that, but K, we don't know K. Yes, we don't know K, but we are looking for T. But luckily, K is equals to ln 2 divided by T half. And we know our T half. So that implies to look for K, we'll take K equals to ln 2 divided by T half, which is 40.13. Having our K now, point that on your calculator, we'll have 0.017 per second because we are dealing with the first order. Now, back looking for the time after initiation of the reaction, T is equals to 2.303 divided by K, which is 0.017 times log 100/10 the reacted percentage. Punching that in a calculator, log 100/10 will be log 10, which is 1. Punching that, we have 135.47 times 1. So T equals to 135.47 seconds. So that's that for question 1, Enzymology BCH 401. Thank you for watching. You are welcome. Please don't forget to subscribe so more tutorials and notes explanation. When it's uploaded, you will be alerted for that. Thank you. Stay tuned to this channel, GENUIS Grade.